this is the virtual unit preview for Unit 4, Geometry, Quadrilaterals, and Transformations. The global context for this unit is scientific and technical innovation, with the primary question being, how do we understand the world in which we live? Keywords within the scientific and technical innovation global context was digital life. We have a project exploring how we can manipulate shapes digitally to create specifically an animation. Key concept would be form, because we are looking at shapes and what they're doing in the coordinate plane. And then change and representation are the related concepts. All of that leads us to the statement of inquiry. When shapes change digitally, the physical transformations can be represented in various ways. You guys can take a look at the factual, conceptual, and debatable questions. For the debatable questions, you guys can talk about technical innovations and whether the world would be better or worse off with them. I think an interesting one would be like cell phones. Are we better or worse off? You could talk about things like communication. Does it help us communicate better or worse? Talking about the accessibility of knowledge. I think some of those answers are pretty obvious, but I think some could spark good discussion with the kids. Another good debatable question would be, are today's technical innovations more or less significant than those from the past? I would suggest maybe printing some articles on recent technical innovations so kids are aware of what's happening right now, because I think in history class and the kids are aware of what has happened in the past, but maybe focusing on what's present and then discussing, having a debate about which ones are more significant and why. You can see the teaks. The bolded ones are the readiness teaks, what scholars will need to know and they will be skilled at. I'll let you read those on your own. Interdisciplinary connections. So this can be connected to engineering. There's a lot of cool resources on code. So code is used in the creation of computer programs that allow engineers to do their job with efficiency. Programs can take certain inputs and give appropriate outputs much faster than humans can do by hand. If you go to code.org, it'll let you play little games. The kids can learn so much about code. So if you have an extra class period, I would encourage you to go to code.org and explore that with the kids. I think they would really like it, and it would be pretty eye-opening for them, especially if they have a technology course in high school, which I know my kids do. For art and media, animations are a series of individual movements that, when sped up, look seamless. Animation for Aladdin started when an illustrator would draw several illustrations of each key movement in a scene so that the computer animators would know how to create the same motions with their animation programs. You can see the some flip animations in that YouTube link, which is pretty cool. The behind the scenes of Aladdin is a good connection for the kids to make, because what they do in Aladdin is essentially what they're doing for their project. This is the animation project. It says the task is to create an animation. You can create a YouTube video, a timed PowerPoint, emphasis on timed, or a flip animation on paper. The animation must be on the coordinate plane so each movement can be tracked. It can tell a story, be a dynamic design, kind of like a screensaver, however they want to do this. So the idea in the YouTube video, the PowerPoint, or the flip animation on paper is to give kids multiple opportunities to present their work, or multiple different ways to present their work. The requirements are that on the coordinate plane, with whatever images are moving around, you must have 5 translations, 4 rotations, 3 dilations, and 2 reflections, and then 1 composite transformation. This is bare minimum. You have to use geometric notation to describe all 15 transformations listed above. The rest of the movements do not need to be notated. So there are more than likely going to be way more than 15 transformations in their animation, but just the 15 need to be notated. You have to fill out the back side of this paper. And if your animation is a paper flip animation, it will be turned in. If it's a YouTube video, send the link via email. If it's a PowerPoint, it needs to be emailed. So you can read the rubric. This is the back side of this paper where they need to notate all of their transformations. So you can see the 5 translations, 4 rotations, etc. Under where you can find it, There's the time, the slide, the page number. So whatever it is, whatever output they give you, whether it's a PowerPoint or whatever it is, they need to say exactly where where you can find that translation, so that you can grade it appropriately instead of searching the whole project for it. And then they need to notate it correctly. Please make sure that the kids are notating correctly. That's a really big deal. It's important that anything that is subscript is written as subscript. I think kids oftentimes want to write all of their transformation rules just straight across on the same line, no difference in size between all of the characters. So that would be an important distinction for the kids to understand. Down here, there are some reflection questions. How did geometry play a role in creating your animation? Please emphasize this. The whole point is to connect geometry to making an animation. If they create the animation, that's fantastic, but having them reflect on how geometry played a role, using appropriate vocab, really reflecting on this question, that's going to be important to reach the 7 or 8 level. Why did you choose to create your specific animation? What inspired you? What transformation did you use the most, and why? Okay. If they need extra space, encourage them to use extra space there. What kinds of professionals do you think might use the concepts of transformations for their work, and explain? This will get them to think more about maybe not just animators use transformations, what other kind of professional job might use transformations. To get them to think a little bit outside the box and be creative and make connections on their own instead of waiting for class. All right, going back to the unit plan, getting into stage 3, which is backwards planning. You can check out some teaching strategies and learning experience. I think using either clear, like those projector sheets that your teachers probably used when you were younger. I don't even know what they're called. That's because we don't use them anymore. Or maybe a sheet protector or patty paper, something like that would be see-through to show what happens when all of the transformations were made. I also suggest having a graphic organizer for all of the different types of quadrilaterals, maybe Venn diagrams in there, all of that stuff, because it's really easy to get all of those quadrilaterals mixed up. Looking at the diagonals, which ones have even sides, which ones have perpendicular diagonals, which ones bisect, etc. Looking at differentiation, those are some ideas for how you might be able to reach more kids in your classroom. Real-world connections. Game designers. In gaming, animations must react to the player's commands. Game engineers must set parameters to the animations and decide which button or movements will cause a character or object to turn, walk, run, jump, etc. I again think that going to code.org will help a lot with this connection, because kids will have to code certain movements within their little game things on code.org. It's really fun. I think the kids would like it a lot if you have time to make that connection to gaming. With MC Escher, he created intricate tessellations by flipping, turning, and moving shapes in an interlocking pattern. This would also be an interesting project to explore in class. It is definitely related to geometry. I just don't think it's high rigor, But in case you are interested, I have done a project like this before in class. I think I did it during an intervention period or sometime after school. It was during a non-instructional day. And it went really well, gave my classroom some decoration, and the kids really liked it. So if you're interested in a project like this, then just reach out to me. So getting into the days, we're going to start off the unit by looking at interior and exterior angles of polygons. Of course, this unit is on quadrilaterals, but we first need to look at, well, why is a quadrilateral 360 degrees? Can it ever be more? Can it ever be less? The exterior angles, etc. Then we're going to get into day 2, which is looking at parallelograms. This is a really big day. There's a lot that goes into parallelograms, and it's quite foundational for the rest of the unit, the quadrilateral portion of the unit anyway. So just make sure that the kids are understanding the concepts and being able to apply algebra to these concepts. So if you look at the exit ticket questions, they not only need to know the properties, but they need to apply, like, what are these expressions in the corner of quadrilateral QRST? What are they doing there? The kids need to know that. So this is going to be a pretty heavy day 2. So break it up if you have time. But otherwise, just see how it goes. For number 3, day 3, you are starting to look at rectangles, rhombuses, and squares, looking at quadrilaterals in the coordinate plane. This is also a pretty big day because it's easy to confuse the properties of rectangles, squares, and rhombuses. So slow this down a bit if you feel the need. Otherwise, just make sure that the kids understand the concepts and can apply algebra to them. Day 4 is looking at kites and trapezoids. This is, I guess, in terms of how many objectives you have, it's an easier day. But by day 4, the kids have learned so much, and it's all brand new to them, that you might need to take a review day if you have time. I know that it's hard for my kids to keep everything straight. So I know for myself, I'm going to need to slow down here between days 1 and 4. Getting into day 5, you're starting to look at translations and dilations. So again, make sure that you emphasize proper notation. If something is subscript, then make it subscript. Naming the coordinates correctly, using a T, lowercase capital, right? All that stuff is really important for them. Being able to look at a graph and write the rule versus look at a rule and draw the graph. That's important, going back and forth like that. Day 6 is reflections and rotations. So again, same thing, just focus on the notation. The rotation formulas are not given. So these formulas right here are not given on a formula sheet. So the kids will need to know them unless they want to figure it out themselves when they get to a test. You can also do pretty cool investigations on this as well. Day 7, you're drawing compositions of transformations such as glide reflections. The kids need to know the difference between all of the different types of transformations in order to get to this day. Make sure that you talk about order matters, how to write the rules with the open circle, all those things. Day 8 then is the exam. There's no review day built in here. You're just going to have to pace yourself. And again, I've been saying, if you have extra time, then slow down. Just see how time goes for you. If you can review an extra day, then that will be fantastic. But if you pace yourself appropriately all the way up until the exam, then you might not need a review day. So I filled out the prior to the teaching the unit box. I mentioned code.org. The animation project is an attempt at exposing our scholars to the formulas behind movement we see on screens every day. While the movements may not be described using proper geometric notation in the real world, it's a way for our scholars to understand the different pieces of the big picture. Introducing all these transformations in days 5 through 7 would be more powerful via investigations, which is what I had just mentioned with the rotations. There are lots of investigative worksheets, projects out there floating around in the internet. I also have some if you want to reach out to me, but investigations would be fantastic for these transformations. If you guys have questions on this unit, please reach out.